Okay, so types of the chopper. Chopper is a types. What about that one? How it is classified? The output of the voltage base, the chopper is classified into the three types. One is a buck or step down, or the second one is a boost or step up, or combination of these two, buck and boost. That's all. So these three is classified of the chopper: buck converter, boost converter, and buck boost converters. So here I am not write the names. So please note it down: buck converter, boost converter, and buck boost converters. So these three, what is that one? If I have see these three, okay, these three type of the circuit, it consists of the three main, okay, devices. It consists of the three main devices. What are the three main devices? One is a switch. One is a switch. So what is a switch? The switches maybe for you are going to use controlled switch, maybe you will going to use MOSFET or IGBT or GTO, any one type of the switch you can take it. Then second one is, what is that one? Diode. Okay, so diode and the inductance. These three is the only device. So these three device used to, you will going to make about the buck converter, boost converter, and buck boost converters. Okay, then next one, first we'll go ahead on the buck converters. So buck converter, another name is called step down converter. Step down, I like the name for that, step down. Y means S for that switch, and D for that diode, and one more device is L. So you will going to make the combination of these two, 1, 2, and one more is will inductance you will going to make. That's all. Step down converter is over. Then that is called, another name is called buck converters. The next one will go for the next converter name, that is called step up converter. Step up converter. What is circuit diagram for step up converters? So that is very simple. So I will going to give for take for the buck converter 1, 2, 3. So I want to rotate on that anti-clockwise. If I will going to rotate on the anti-clockwise, so it is coming first one. What is come that one first place? So in 3, 1, 2. So write it on that one, 3, 1, 2. You should be right. First one anti-clockwise, and 3, 1, 2 you should be right. Then you will going to make it. So inductance. Okay, 3 play. Okay, the in 3. Then 1 is, what is that one? Switch. Okay. Then what is the remaining? Then 2. Okay, that one is called a diode. Yes. So that's all. So this is called boost converter. That's all. Boost converter is over. Circuit diagram of the boost converter is over. So how to you will going to draw? No need not to, you can memorize it. Just anti-clockwise rotations. So give the numbers 1, 2, 3 anti-clockwise rotations. Then you will going to write 3, 2, 3, 1, 2, 3, 1, 2. Then give that one here. What is that? 3 is coming, 1 is coming, and 2 is coming. That's all. So you will going to develop about that boost converter or step up converters. The next one, buck boost converter. What is a buck boost converter? So I will going to take from the first one is a buck, switch is there. Yes, I will going to draw the switch. Okay, then over. So input side is a switch is over, and the buck is I have drawn. Boost converter. So boost converter means, what is that one? Output side is a diode is there. So it's the third one. So opposite. So diode is the opposite I have connected. Okay. Then what is that one? Switch is I have connected, and the diode is over. And what is one more terminal? That is called a device is a inductance over. So we will going to develop the circuit that is called the buck boost converter. That is called a buck, and that is called a boost. Then it's a combination. It is called a buck boost converter. Buck boost converter. It is a already developed the circuit diagram. Over. So circuit diagram, you want to know how to draw the circuit diagram, easiest method. Okay, fine. That's all. Let's we go ahead on that one topic. Okay, what is a buck converter? Buck converter means say for example 50 voltage I am going to give for that input voltage. So what is output voltage? 25 voltage. If it is output is 25 voltage means, so output voltage is low or high. Compare with that input voltage, output is a low. So low down, that is called a buck converter or step down converter. So then write about that Vs input is greater than V naught. So input is higher than, compare with that one V naught you can compare, it is input is higher. Okay, then input is a 50 voltage. Input is a 50 voltage. Then output is 100 voltage. Output is 100 voltage. Thus output is higher or not? Yes, output is higher. That is called the boost converter. That is called the boost converter. Then you can write, so V naught greater than Vs. So output voltage is higher than the input voltage. Output is higher than the input voltage. That is called the boost converter. Then next one, buck boost converter means what? So I will going to apply for that one 10 voltage as an input. 10 voltage as an input I will going to apply. My output is I need for that 20 voltage. Yes. So you can get the 20 voltage boost operation. Boost. Suppose I am applying 10 voltage. I need output is a 5 voltage. What to do? Yes, buck operations. How is it possible? This is you will going to apply the firing angle. This firing angle you will going to give the variations to get the boost as well as buck operation. That's all. So this is called buck boost converter. Buck boost converters. So this is about the 3 converter majorly. Okay. Then further we're going to go deep about that step down converter or buck converter. So there are 2 circuit diagram. So what is this 2 diagram? One is a switch is there, diode and inductance. So here is a inductance is I have removed, no inductance, and the diode also not there. So what it will happen? It's a what is the load I have used today? Resistance load is used. If you are using for that RL load means you should be used for that freewheeling diode. Okay, if it is a no RL load, only I am using R load, so need not to you can use for that one any freewheeling diodes or diode is not needed. So this is a simple. What is that one? Very simple. So whenever switch is on, okay, here I will going to give that one 10 voltage I will going to give. So 10 voltage I will going to give. So when 10 voltage is coming, whenever switch is on, the 10 voltage is coming to the output. That's all. 10 voltage is coming to the output. So 10 voltage you can apply, 10 voltage coming to the output. That's all. Switch is closed. Okay, switch is closed, 10 voltage is coming. If switch is not closed means it's a 0 voltage is coming to the output. So switch is closed, then 10 voltage is coming to the output. So does it in that circuit? Okay, any filter is used? No filter is used. No filter is used. Then what is output waveform? Did you see my DC chopper practical video experiment? If I have seen that one, you will going to coming to know that one the output waveform is a square wave is produced. The output is a pulsating DC, that is called a pulsating on off pulsating DC is produced. Why the pulsating DC is produced? Because no filter, no inductance, so no inductance is used. Okay, that's why it is going to produce as a pulsating DC. Okay, that's why it will going to produce the pulsating. Suppose I will going to use the inductance, either here I will going to use or here I will going to RL load I will going to use. So what it is a response. So that one you will going to see. Okay, first one in the circuit you will going to understand. So here I am not use neither RL load nor inductance is used. Only one switches are used. So my waveform is this is a waveform. My output voltage waveform is output voltage and output current. You know, R load means output voltage and output current is both also similar. Both also similar. What is the waveform? So the waveform is a pulsating type of the waveform. Pulsating type of the waveform. On off on off on off on off. Pulsating type of the waveform. What is output current? On off on off on off. It's a pulsating DC. Pulsating DC. Okay, if you are going to use for the inductance here, inductance is used. Either you can use the inductance here or you will going to use RL load. So in the condition what will happen? Your output current you can see. So your output current is a continuous current. Continuous current, that's all. Your output current is a continuous. If you are using the inductance, your output current is continuous. Output current only. What is output voltage? On off on off on off on off on off. So you are not, I am not using any filters. As per the circuit diagram, I will make the circuits and then I will going to use for that one here. I will going to use for that load. Okay, here I will going to use and then I will going to measure what is the output waveform and what is the output current waveform. Due to the inductance, what will happen? On, okay, during the time on time, it is getting the charge. It will going to get the charge. During the off time, it is a discharge. So during the on time is charge, off time is discharge. How it is like, how it is working? Okay, how it is working? So that's why we're going to see about the mode diagram. There are two mode conditions. Mode 1, what is that one? Mode 1 condition, I will going to close the switch. If switch is closed, what will happen? Switch is closed here. So whenever the switch is closed, diode is open. So diode is open conditions. So here is a diode is open. Okay, switch is closed, diode is open condition. So what will happen? Then input voltage, either 10 voltage or 20 voltage, whatever you are going to apply, it is start to flow from the input to the switch to the L to the load to the closed circuits. So 10 voltage apply, same 10 voltage is coming. either with inductance or without inductance. That is your questions. If your inductance is there, what will happen? The inductance, it will going to get the charge during the mode 1 time. Inductance is getting the charge. Inductance is getting the charge. So if it is inductance is not used, no problem. So no inductance. So during the mode 1, so power supply to the switch is closed, then switch to the load. Yes, this is a mode 1. All of you note down. This is a mode 1. Write the path. Mode 1 is equal to source Vs, then Vs to the switch CH, then CH to the, then L to the load, LOAD load, then load to the Vs minus. So this is a path you all of you write. This is a mode 1 path. Okay, if you are using the inductance, or if you are not using the inductance, so directly it is a go. Okay, during the mode 1, what is happening? So 10 voltage you are going to apply. This 10 voltage is coming to the load, 10 voltage as well. This inductance is getting the charge. The inductance is getting the charge of the 5 voltage, for example. It will going to get the charge. So over. So once again I will repeat. Mode 1 condition, switch is closed, diode is open. So at any time, okay, either a switch is closed or diode is closed. Any one is closed. Okay, switch is now closed, mode 1 condition. I will going to apply the pulse. Diode is open. So here is the source is a flow to the load. So the meantime, inductance is getting the charge. It will going to start to increasing the charge. Okay, fine, good. If it is no inductance, no problem. Okay, what is the mode 2 conditions? During the mode 2 conditions, the switch is open. The diode is closed. The arrow mark based, it is a closed. Okay, diode is closed. Switch is open. If the switch is the switch is open, diode is closed. If the switch is open means does the source is a flow to the load? If switch is open during the condition, does source is a flow to the load? No. Why? Because switch is open. Okay, then what happened? Then what it will do? Already stored the inductance. For example, 5 voltage. I said last mode that 5 voltage it will going to discharge. How it is a discharge? Yes, here you can see this is a closed path. It will going to start to discharge. Start to discharge on the closed path. So if the condition, what will happen? Okay, it is a short circuited. During the short circuited, what about the output voltage? Why it is short circuited? You can see it is a short circuited. So it's a simply shorted. The diode is closed means across that one it is a short circuited. So during that one, so what about the output voltage? Short circuited condition, output voltage is 0. Yes, that's why mode 2 is a 0. So what will happen? This is a stored inductance. Mode 1 condition get the charge. Then during that mode 2 condition, it will going to discharge. So that's why it will going to start to discharging. Mode 2 conditions start to discharging. That's all. This is very simple. Okay. So mode 1 charging, mode 2 discharging. Okay. So once again I will tell you. So mode 1 condition, switch is closed. Okay, switch is closed, and this is a open. Okay, diode is open. So power supply to the one switch to the L to the load. It's a close the path. So now it's a 10 voltage means same 10 voltage you are going to get. As well, this inductance is a 5 voltage. It will going to get the charging. 5 volt to get the charging during the mode 1. So what will happen? Source is the same source to the load. That's why during the on time it's a high. And the inductance is start to increase the charging. Charging. Yes, it is increasing. Okay, what about the off time? So during the off time period, the switch is open, diode is closed. Okay, then it is already 5 voltages there in mode 1 charged. Now start to discharge. Okay, it will going to start to discharge. Yes, it's a discharge. So what about output voltage? It's a short circuited. So short circuited means short circuit across the load. It's a 0 voltage. So 0 voltage. So that's all about the mode 2 conditions. Okay. So if it is inductance is present, no inductance. So I need not to worry about the inductance. So only one mode. So what is that one? Okay, here is no inductance is there. So it will going to start to flow. Okay, that's all. It will start to flow. Yes. The switch is on, at a time it is start to flow. When switch is off, it is a current is also off. So switch is on and off. Switch means it is based on the frequency wise on off. on off, on off, on off, it will going to